Hey, what is up, ladies and gentlemen, boys and girls? Welcome to another episode on the Incredible Academics YouTube channel. And guys, we continue with what we call geometric series. Okay, in fact, we're not continuing, we're starting with geometric series because remember, we were looking at geometric sequences. As always, we start with sequences and then we start talking about series. Okay, so today we're gonna be discussing what? Geometric series. And that is just a build up from geometric sequence. Okay, so obviously you guys already know the meaning of series, right? So remember, we're having something like this. We had 1 and then 2, 4, 8, 16, right, 32, right? So I mean, this is a sequence. Okay, and to find what we call the general term, we check, okay, is this geometric, is this arithmetic, and is it quadratic? But it's geometric, okay, because the constant rate, the r, is what? 2 over 1, 4 over 2, 8 over 4, so the r is 2. Okay, so now we know that the general term is given by what? A r to the n minus 1. So the first term is just 1 times the r is 2 to the exponent n minus 1. Okay, so now that becomes what? That becomes just 2 to the exponent n minus 1, right? 2 to the exponent minus 1. So that is our general term for the sequence. Okay, but now as soon as we start having something like this, 1 plus 2 plus 4, 8, 16, 32, Now this is a different thing. It's no longer what we call sequence. It's series. But remember, with series also we need to know, is it geometric, is it arithmetic, so on and so forth. Okay, but because this is derived from a geometric sequence, it then becomes a geometric series. Do you understand? So there's that relationship, right? So what if I asked you to find the sum of the first 6 terms, literally these terms here, without the use of a calculator? I mean, without just manually punching 1, 2, 4, 8, 16, 32. How would you do it? All right, so with our geometric series, we've got a formula. The sum is equal to the first term and then 1 minus r to the n divided by 1 minus r. This is when r is less than 1. Okay, and then Sn is equal to, Sn is equal to a into r to the n minus 1 all over r minus 1, and this is when r is greater than 1. When r is greater than 1. So that's your sum formula, okay, for a geometric sequence. Okay, so yes, now let's find this sum over there. Okay, right? What is the first term? The first term, so we're going to check, okay, the r is actually greater than 1, so meaning that this is the formula that we're going to be using. Okay, so we know the first term is 1. Remember the a, that's the first term, and then r is what? The r is 2. You guys have seen from the from when we're finding general term up there. So so it's 2 to the exponent n. n is just the total number of terms here. 1, 2, 3, 4, 5, 6 terms. So 2 to the 6 minus 1 over r minus 1, 2 minus 1. So what are we getting here? Let's punch everything into the calculator and see what answer we're getting. Okay, so it's just going to be 2 to the 6 minus 1 over 2 minus 1, which is just 1. And the answer is 63. We're getting 63 here, but let's manually, sum the numbers there and see if we're still going to get 63. So 1 plus 2 plus 4 plus 8 plus 16 plus 32. We're still getting 63, so the formula is actually working. Okay, but there's something that I'm also kind of curious about, right? That what if we used that formula instead of this one, despite the fact that r is greater than 0. So let's try that. So Sn would be, the a would still be 1, and then 1 minus, the r is 2, the n is 6, right? Sometimes you just gotta do experiments, guys. You just gotta become a scientist. And then 1 minus 2. 1 minus 2. Let's see what we're getting. So 1 minus 2 to the power of 6 divided by 1 minus 2. 1 minus 2. We're still getting 63. We're still getting 63. So let's forget about this formula. Let's forget about whether there's r less than 1, there's r greater than 1, because I know to some people it becomes very, very confusing. Let's just stick to this formula, because I mean, either one gives exactly the same answer. Okay, exactly the same answer. So when they ask you what is the sum formula for a geometric series, this is the one. Okay, let's just stick to one formula to save time. Okay, so that's it. We now know how to find the sum when we're given a geometric sequence. So, but now, what if we were asked to find, so what if they said, okay, it's fine, you've got 1 plus 2 plus 4 plus 8, so you guys can see, plus 8 like that, right? And then they ask you, write this in sigma notation. Sigma. Okay, remember sigma notation is when you've got this, and then n is equal to some number. Most of the time it's 1, and then it ends at some number up there, and then you have to write the general term of whatever sequence that you have over there. Okay, so we already got our general term. Remember, general term is 2 to the n minus 1, so meaning that we can immediately write the 2 to the n minus 1 here. So 2 to the n minus 1, that's the thing that we write there, and then n starts from 1. Okay, so by this sequence here, 1 2 3 4, it ends by term number 4. So that's how you can rewrite that in sigma notation. Okay, sometimes they're just going to give you this and then they ask you to evaluate. Okay, they ask you to evaluate. So let's just find a question quickly and then do the evaluation so that you guys can see exactly how we evaluate. Okay, so just a second. Just a second. Okay. You see now this is taking forever. But let's just assume that we've got this. All right, let's suppose that we've got the sum from n equals to 1 to n is equals to 10, right, of what? Of let's say we've got 3 into 1 over 2 n. Should we say minus 1? Okay, just n. Okay, and then you ask to do what? To evaluate. Right? So to evaluate here, you can already identify the r. So the r is what? R is equals to 1 over 2. And because there's exponents and all that, we already know that this is a geometric series. It's not sequence because there's the sum formula, sum sign, right? It's series. So r is equals to 1 over 2. All right, this here. Okay, whatever base that you identify, that becomes your r. And the a as well, that's so important. The a, you just substitute the first n here. So 3 into 1 over 2 to the exponent 1. That gives us what? 3 over 2. So we've got the r and the a. But we also need to find the number of terms, right? The total number of terms, n is equals to this one, 10, plus this one, plus 1, minus 1, and which gives us what? 10. You know, it's easy to figure out that the total number of terms in this case, it's 10. Okay, but if you had a situation like this where n is equals to 4, the first term is 4, is at 4, right? And then we still got the 10 there, and then 3 into 1 over 2 to the exponent n. Very, very difficult to figure out the number of terms here. Okay, so n then becomes 10 10 minus 4 plus 1, right? Which is 10 minus 4, that's 10 minus 4, that's 6, plus 1, that is 7. So from 4, 5, 6, 7, 8, right? That's 5, né? 9, and then 10. So the total number of terms is 7. So I made a mistake here. 10 minus 1 plus 1. So you always find the difference between the position for the last term, which is always up there, and the position for the first term down there, and then you add a 1. Then you find your n. Okay, so I was just giving you a heads up there, because sometimes n is not gonna be 1. I'm telling you at the bottom there. So okay, we know that total number of terms, it's 10. So that's all that we need to be able to evaluate. So Sn is equal to a into 1 minus r to the n divided by what? 1 minus r. So we know the first term is going to be 3 over 2. That's cool. 1 minus the r, it's 1 over 2, and the n is 10 divided by 1 minus 1 over 2. Okay, 1 minus 1 over 2, and that becomes what? We can quickly use our calculator to figure that out. So 1.5 into 1 minus 0.5 to the exponent 10 divided by what? 0.5. 0.5. So that gives us 2, that's 3.0. So the sum is basically 3. Okay, so we have evaluated the same way we were, doing the evaluations there by what we call the arithmetic series. So that's that. And there's also what we call sum to infinity, but we we'll talk about that shortly. But I hope and believe that we have kind of like introduced geometric series, especially because we've covered this formula here, right? So now you guys have an idea about how to find the sum. Okay, I want us to also do some I want us to look into a slightly different question. So let's suppose that you've got your 1, you've got your, so it's 1 plus 3 plus 9 plus 27 plus no, I mean I think that's enough. So 3 to the exponent 10 minus up to 19,683. So plus, and then they ask you to find the total number of terms in the series. Find the total number of terms in the series. And remember, even when we're dealing with arithmetic series, to find the total number of terms, you have to find the total number of the position for the last term. And you can see that here, this is our last term. So if you can find the position for that, then we know that the total number of terms is just going to be equal to the position for that last term. So to do that, we need to find the what we call the general term. So to find the general term, obviously remember the general term is like this: Tn is equals to a r to the n minus 1. That's simple. So but we need to figure out what the a is. A, we already know that a is 1. Also, we need to figure out what the r is. All right, r is simply equal to 3 over 1, 9 over 3, so on and so forth. So it's basically 3. Okay, so let's do the substitution. We've got the a and the r. 1 times 3 to the exponent n minus 1. So 3 to the n minus 1 is basically our general term. Okay, so now we're going to do this. We're going to say, okay, to find the position of the last term, we simply substitute the last term in place of Tn. That's what we've always done, even in grade 11, finding the position. That's what we need to do. So 19,683 is equal to 3 to the n minus 1. All right, so now what we're going to do is we're going to say, okay, can we write this as base 3? What's on the left hand side? Can we write that as base 3? And normally how we do it is we go into 19,683. We just punch it into the calculator. We say equals to, and then we shift, and then we fact. All right, 19,683. So it seems like we are not getting it, because you can see that it's giving us some weird numbers. So maybe we still need to do this. 19,683 is equal to, we split this 3 times, remember this is the same as 3 to the n by 3 to the negative 1. Okay, so meaning that we can multiply the left hand side, and also this is the same as 3 to the n over 3, right? 19,683. So now let's go right ahead and multiply on the left and on the right by 3. Okay, so 19,683 times 3 times 3, that gives us 59049 is equal to 3 to the exponent 3. So let's see if 59049 can be written as a power of 3. It's 3 to the 10. 3 to the exponent 10 is equal to what? 3 to the n. Okay, can you see that? Now we've got the same basis, so we can drop the basis and equate the exponent. So n is equal to what? 10. Therefore, total number of terms is 10. Okay, so what if they then went on to say, okay, hence, in other words, carry on from whatever that you've been doing, hence find the sum, right? So it means that we just, continuing from whatever that we've been doing. Okay, so find the sum. So we know that Sn is given by a into 1 minus r to the n. Remember I said forget the other formula, we're using only one formula for finding the sum. So this is divided by 1 minus r. Make sure that your things are consistent. When you say 1 minus r to the n at the top, in the denominator you must also say 1 minus r. So that becomes what? This is equal to this is equal to what? So the a, we know that's the first term of the sequence, which is 1, easy this time around, and then 1 minus the r is what? R is 3, and then to the exponent 10, because remember to the number of terms it's 10, and divided by 1 minus the r is also 3, so we're minusing 3 there, and there we punch everything into our calculator. So 1 minus 3 to the exponent 10 divided by 1 minus 3, and the answer is 29,524. That's the sum. Okay, so I think we have we've had a conversation too long, right? So I think I'm gonna seal it right here, and until next time, I hope you guys enjoy the lesson. Yeah, let's spread the word. Maybe there's someone that needs to have access to the channel. Please let them know, and that's it from me. Shout out.